In this video, I would like to introduce what the photonic crystal is. Photonic crystals are normally classified by their periodic structure. One-dimensional photonic crystal has a periodic structure in one direction, while two or three-dimensional photonic crystal would have a periodic structure in two or three directions. One-dimensional photonic crystals were discovered in the 1887, while two- and three-dimensional photonic crystals were not discovered until around 1787. Photonic crystals are optical materials created by periodicity stacking layer of elements of differing optical parameters. These periodic medium are made of at last two materials having different electric constant or epsilon. Photonic crystal utilize the existence of photonic band gap that form from periodicity among material to limit the propagation of light along certain wavelength to produce desired effect shown in this figure. The photonic crystal can do as much as direction light along a certain path or even stretch travel certain wavelength. In the principle, photonic crystal can be used wherever light is present and can be manipulated more specifically. Photonic crystal take advantages of the light reflected from the material. Photon enter the crystal and only certain frequencies uh, reflect out due to the periodicity. Photonic crystal only reflect certain wavelength of light because of photonic band gap. Photonic band gap are range of frequencies for which no wavelength of light exists in the medium. We have a graph of wave number versus frequency. For a non-photonic crystal with a form medium, by treating it like a periodic medium, we can fold the wave number over at A plus or minus V over A. With this new fold graph, we can see the point of reflected at K equal V over A. That positively sloped portion of the line around the point is represented by cosine of V times X over A, or while the negatively sloped portion is represented by sine of V times X over A with a uniform medium. Both of these functions are equal to each other at K equal V over A. However, once we add the periodicity of photonic crystal, the gap formed between the upper part of the line, the sin function in the lower part, and the cos function, because two functions are no longer equal at V over A, which in turn form a gap which the frequencies no longer exist. They discover properties of one-dimensional photonic crystal was then applied to two- and three-dimensional photonic crystal. There are several types of three-dimensional photonic crystal. The most common of which being wood file structure. Other types include the spheres in a diamond lattice and impulse oval. The figure show the photonic crystal may be applied in the something like a fiber optic cable by allowing only certain wavelength of light through the rays propagate long length of the tube. Here, some more cross-section of the most popular use of photonic crystal by man fiber optic cable photonic crystal are also used in clothing light, gift wrapping, makeup, and other eyes flashing application. In addition, the man-made instance of photonic crystal also appear in the nature. So here you can see some different examples such as beetles butterfly or peacock's feather natural photonic crystal also appear in various stone, most well known being opal. I think this is the introduction of the photonic crystal. Thank you very much.